I want to tell you about integration by parts. Integration by parts is the direct consequence of the product rule. Suppose you have some f of x times some g of x, and suppose if we want to take the derivative of this product. The product rule tells us that we have to multiply f of x by g prime of x and add it to g of x times f prime of x. Okay. Now let's go ahead and take integral of both sides. So integral of left-hand side, and then take integral of all the right-hand side. On the left-hand side, I will get, well, of course, this cancels out. So I have f of x times g of x. And on the right-hand side, I will have integral of f of x, g prime of x, dx plus integral of g of x, f prime of x, dx. And now, for the sake of simplicity, I'm going to go ahead and swap the left-hand side with the right-hand side. So now I have integral of f of x, g prime of x, dx, plus integral of g of x, f prime of x, dx, all that equal to the product of f of x times g of x. And now I'm going to go ahead and subtract this part from both sides. So now if I do that, I will get integral of f of x, g prime of x, dx equal the product of f of x, g of x minus integral of g of x, f prime of x, dx. Okay. And so to make this just a little simpler, we are going to let f of x equal u. So let's let f of x equal u, and let g of x equal to, say, v. Now, using this substitution, I can write that integral of u dv equals u times v minus integral of v du. And so now that's our formula. Let's have an example. Let's use that and have just one example to show you how powerful this integration by parts can be. So we want to, first of all, let me write our formula up here so we can keep referring to it. At the end, we had that integral of u times dv equals u times v minus integral of v du. So now our example, let's see, how about integral of x e to the minus 2x dx. Okay. So now, looking at our formula, I'm in need of u and dv and v. So I'm gonna, let me use a different color. Let me use red. So I'm gonna let u equal x, dv equal e to the minus 2x, e to the minus 2x. And so since u equal x, if I take the derivative of both sides, I will get du equal dx. Okay. And what else do I need? I need to have v. Well, if dv equals e to the minus 2x, and if I take integral of both sides of that, I get integral of dv is just simply v. Integral of e to the minus 2x is e to the minus 2x. Using chain rule in reverse, I'm going to have to divide by -2, so I get -1/2 in here. And notice that I'm not going to write plus c at this point. Why is that? Not that it's wrong, it's just that it'll keep things cleaner. We just add our constant at the very end, so bear with me. So once again, here I could say plus c, but I'm not going to do that. And I certainly recommend for you not to do that and just leave it for the very end. Okay, so now I can claim that integral of x e to the minus 2x dx equal, following the formula, u times v. So u, which is x, times v, which is -1/2 e to the minus 2x, and minus integral of v du. So maybe I'll write that a little bit farther down for the sake of fluency. Of integral of x e to the minus 2x dx equal u times v -1/2 e to the minus 2x minus integral of v, which is -1/2 e to the minus 2x times du, which is same as dx. Okay, now I can simplify this one baby step. So this equals, let me write that, integral of x e to the minus 2x now equal -1/2 x e to the minus 2x plus integral of, well, let me, negative times negative is positive, so plus 1/2 integral of e to the minus 2x dx. And so integral of this, I already know. I have done it in here, but so this equals -1/2 x e to the minus 2x plus 1/2 e to the minus 2x. Using chain rule in reverse, I have to multiply it by -1/2. So this equals -1/2 x e to the minus 2x. And I do have, okay, -1/4 e to the minus 2x. Now I'm going to put plus c. Now I'm going to put the plus c because I'm pretty much done. Can I simplify this? Yeah, I have e to the -2x in both of them, and -1/4 is a common factor. Let's pull that out. So this equals -1/4 e to the minus 2x parenthesis. So I need a 2 in here, I need x in here, and I need a plus 1 plus c. Okay, so in the beginning, getting the antiderivative of original problem seemed to be really difficult, but not so with integration by parts. Well, I'll be doing more examples for you pretty soon. Thanks.